My name is Alexander Tavgen, and I worked in different positions in engineering field or architectural one. And in this lightning talk, I want to present some way how we can make our Java development more friendly to the cloud. As you know, Java is quite old. It was born in 1996, and main benefit was that you can run your code everywhere. So you have some sort of abstraction from your hardware, and it was quite beneficial at that time. And Java evolved quite well, but most of its benefits became weaknesses in cloud environment. For example, slow startup. JVM needs a lot of internal classes just to start itself. It has a quite large size, which means that you have not so efficient resource usage comparing with native images, and just-in-time compilation not working well in cloud environment because you have a nodes that can go down at any time in cloud, and just-in-time compilation needs a time to compile some hot blocks of code. And again, memory footprint. JVM is thirsty for the memory, and it's not developer joy. What I mean is, for example, in Node.js, you can change one line of code and immediately see results on your screen. There is some technologies in Java like Variable which solve that problem, but if we talked about JVM per se, then those problems are related with the cloud environment, and actually they were solved. So we have a sort of techniques how we make Java more cloud friendly to our modern infrastructure. So, for example, we can use ahead of time compilation and transform our artifacts to native images, which will significantly reduce size and reduce the startup time. We have a framework such as Micronaut, Quarkus, and you will hear about that at this conference as well, which based on Grail VM, which gives ability to compile your images or artifacts in a native image. And Jigsaw also gives the ability to reduce final artifact size, so modular approach, where you can put your application using just what you need, and the reactive approaches as well, which I explain further, and developer joy. So right now, Quarkus has the ability, for example, to recompile on the fly, and which we had, for example, the same way with JRebel. And the main thing is architectural shift. I mean that it's not about that we have some sort of toolkit, but we also need to shift our development paradigm to a new way of thinking or making an architectural decision. So it's reactiveness on all level. What does it mean? So if we talk about reactiveness on all level, we can see that this approach is used starting from development application using reactive approach up to architectural one, where we have, for example, event-driven system which use some sort of event persistence and separation of data change, writes and reads. So it gives the ability to balance different kind of loads or requirements between different scenarios. And Reactive Manifesto tells that what we want from that, we want responsive systems, which is quite related with high availability. Message driven, it means that application or your services work in an asynchronous way. And resiliency and elasticity, it means that we want to from our system that it copes well with a different kind of load, and it was adopted in such way. And there is actually a lot of different kind of models which use reactive approach specifically to JVM. For example, actors model, akka, our communication sequential process, working with, for example, some sort of closure or Go, Kotlin coroutines, and Java reactive interfaces. So even if you want to use reactive approach with your application in development time, you can you have plenty options to choose. And main benefit is related with non-blocking processing as well. So in a classical way, we have our call to database, we have our call to another service, and your application is waiting for response, which is not so effective way of working. Reactive approach with non-blocking processing gives an ability to send request and process the logic further, and when data is returned, you can handle this data as well. And I want to show some small test. We have a 2,500 units of work scheduled once in a minute. In a classical way, you proliferate threads, and I want to show the comparison between reactive non-blocking execution and classical one. So you can see that if we proliferate 2,500 threaded starts, then you see that every thread actually executes only small fraction of time. And you can see that we have quite increased CPU activity and memory. And comparing with the reactive approach, you can see that CPU usage is significantly low comparison to previous one, as with memory footprint. And let's compare one more time. You see that changes between CPU usage and memory is significant one. And we do not forget that threads is also a limited resource in our operation system. You cannot just open thread every time you want. And for comparison as well, one reactive instance can load up one database instance. Comparing with the classical one, for example, I need 3, 4, 5 instances as well. And one of the main things which also brings a lot of benefits is CQRS. So we separate queries or reading our data from the command. Command, I mean, could be anything, but usually it has some sort of relation with data change. What does it give to us? One of the main advantages is we can store our events, for example, in Kafka, and it means that we can replicate our system just by replaying our events from the beginning. So you can recreate your state of your system, not for example, for current state, but you can have some sort of time machine. You can return to the future and recreate state, I don't know, 1 month ago, 2 months ago. You have reproducibility, so you can recreate your environment where you want. You have immutability and eventual consistency. It means that you can replicate events amongst different data centers, and at the end, you will have the same state in all environments. It is cloud friendly because you can have easy deployments, because you store your event in a separate middleware, and that's actually why Kafka is so popular as well, because it gives the ability to use some benefits with this approach on a wide scale. And there is a lot of things related with the CQRS architecture. We can, for example, depending on our scenario of usage, put more attention, for example, on scaling query part, because, for example, if we have more reads and writes, like in some sort of social network, or vice versa, if we have a lot of changes, we can scale more the event, our event bus. And I know a lot of companies who hold the whole amount of events for years, and I know that it's gave a lot of benefits in terms of backupping and restoring. Yes, sometimes it takes some 3 hours to restore the final state, but they can replicate any type of a system at any time of the moment in any data center. So the main thing that were solved with a new toolkit such as Quarkus and GraalVM compiler is that we reduce the image size, the artifact size. We put our attention on fast startups. We mostly do not need too often just-in-time compiler, for example, if we want to go serverless. So I hope that, and I see that there is also a lot of efforts about making JVM much more cloud friendly, more and more. So we will see a lot of new framework development further, for example, the Quarkus as well, and we see that shift and moving toward new paradigm of thinking or creating Java application just has begun. Thank you very much.